Debugging games is not always a simple task. Many times it can feel like you're lost in a maze of code, not knowing where to find the error. Breakpoints and print statements can only get you so far. Well, what if you could actually see what's happening inside the code? That's where debugging in 3D inside the game comes to save your day. Today, I'll show you how I built a 3D debugging renderer inspired by ImGUI, and how it's helping me rewrite the entire collision system. If you've ever used any game engine, you might know how simple it can be to call debug.drawLine and have a line show up in the viewport. How can it be called from anywhere in the code? Well, that depends on the implementation, but for my engine, which is in C++, we can use a cool thing. We can define function inside of a namespace instead of having it inside of a class or struct. This way, we can call these functions from anywhere. Good pairing with this is a singleton pattern. Singletons are objects that can have only one instance. This way, when we want to get the object, the same object is always returned, and we can modify its data. This object can collect the debug entities and render them. In my debug system, the singleton handles everything, from its own entities to rendering. The functions inside of the namespaces just add entities to the singleton. We don't need to remove them, since just like in ImGUI, when the singleton renders the mesh onto the screen, it deletes all its entities. This happens every frame. ImGUI calls it immediate mode. Because I want the singleton to be a self-contained system, I put a mini version of the entity component system inside. It's all made very simple. The singleton has its own entities and components. Then it has init and get instance functions to manage creating the singleton somewhere and returning it from anywhere, and render function, which handles rendering. The namespace currently has just 3 functions: addLine, addCube, which adds entities to the singleton, and render, which calls the singleton's render. That's just for convenience. Now I've made all this just to help me with rewriting of my collision detection system. Being able to visualize these complex algorithms is priceless. Look at this example. I want to see the closest point on the capsule line to the triangles of a cube. We can put debug.addCube inside the code with our data to see the cube in the game. With this system, I should be able to work more effectively, visualizing stuff like velocities, vectors, and complex algorithms directly in the game. Have you ever built your own debugging tools? What techniques do you find essential? Thank you for watching. Subscribe if you want.